Thank you very much for the invitation. So I would like to start by, if you can move to the next slide, please. Well, our interest in the lab is actually to simulate more kind of like environmental migration in a sense. But then after 2016, and in Canada, we started seeing all these flows of refugees and immigrants that were taking or requesting asylum. So we, in Montreal specifically, we declared our city as sanctuary city, as well as Toronto that did it in 2013, and so we keep seeing all these cities getting all these new immigrants. So we were wondering, like, how would be this decision process of those immigrants that are very different from the environmental immigrants, but the situation in areas where you have conflict-induced displacement, well, that will be different, and that will have to be studied differently. One of the main challenges that we faced at the beginning of the project was actually data. So we didn't have data. It is difficult to find data sets of this type of the problem. So with this emergent phenomenon, was actually triggering a new organization of the population. And we were thinking and we were looking into what are the factors, and we found that there were many different factors that play a role in the decision process. So in the end, what we were trying to do was to better understand these dynamics, the dynamics behind the migration. And in order to do that, we use a dynamic approach. So that's why we decided to use an agent-based model. If you can move to the next slide, please. So in order to do that, we use NetLogo. We defined 3 different types of agents. So of course, we had some sort of data sets. We had to create our own, well, we have some limited information about the population, like about, when I talk about limited, it's just like we don't have the census data per se. So we were trying to get some Syrian census from 2004, but since the conflict started in 2011, so we were having problems getting the real data set at that time. We use, on this slide, you will see all the list of different data sets that we try to access. So those are the ones that are used in the model. So we specifically took the Syrian study case because it was important to us to better understand. So at the beginning, we were trying to simulate how the Syrian immigrants were deciding to come to Canada, but the scale was kind of like unmanageable. We were not able to determine exactly what the decisions rules were. So what we tried to do was simply divide all the population, and then in this simulation, we will call it like population agents. Then we have migrant agents, and then we have refugee agents. And we limited ourselves to work on this red square area, so the Syria and all the surrounding neighbors. Could you please pass it to the next slide? Okay, so after we gather all the data set, one important thing that I forgot to mention from the previous slide is how we got the information about the conflict per se. So in order to do that, we use a website that is called Syria Tracker. And this Syria Tracker website is actually a crowd sourcing tool that allows all the journalists to share the reports regarding the death tolls. So we use that data set, and we create a monthly database to be able to determine exactly where the death tolls were located, and then create some different layers to input in our simulation. So the key things for us were to actually identify kind of like the livelihood of the pathways that the migrants will take. So we were thinking about considering being able to identify when these immigrants will leave or decide to leave their place of origin. Then the second one will be where will they go? And then the third one is to know whether they will stay at the point that they have decided to leave, or at the point that they arrive, or it will change the destination. So those three aspects, we evaluate them and we simulate them, and that's how we characterize the migration pathways. Next slide. The slide, please. So to avoid problems of lacking of data sets, in order to simulate the entire Syrian conflict, so we define something that we call conflict zones. So for us, those are updated on a monthly basis. The 20 kilometers wide areas around the cities where the deaths have been registered based on these data sets from the Syrian tracker. So based on that, the higher the death toll at a specific zone, so that area will be perceived as a more dangerous for the agents. So in the end, the evaluation or the trigger for the human population to leave is actually a balance or an evaluation between the tolerance and the danger they are facing. So it was kind of like a 50-50. And one of the things, like, as you can see it in the simple equation, is just like, okay, so the conflict score depends on the danger score, and the danger scores depend on the fatalities at a specific point. So the agent will evaluate every month, like, is increasing, is increasing, is increasing. So it has a memory, and it will reach a point where this person will not tolerate more, like the death toll, and decide to leave because it's not safe, because like many different reasons. But it's an evaluation between tolerance and danger. So to add to this tolerance, so we had different characteristics or attributes for each person or agent. So the population will have characteristics of religion, ethnicity, wealth, age, gender, familial status, and then this combination will give a different value of tolerance for each agent. So I'm sorry, next slide, please. So as I was saying, so this is the way that we evaluate the tolerance. You could pass it to the next slide, please. So this is a very simple to explain flow chart of the process of decision. What is important to consider here is that we will, when you see the data sets, of course, we have like a road network, we have all the description of the ethnicity of the population, different features, we have elevation. So, and we did it that way because we will have, when the decision process of the agent to leave, when the population agent becomes a migrant agent. So in order to move within Syria, they have to decide how to move. So depending on the wealth, like you will be able to move like by foot, you will be able to take a car, you will be able to take a bus, well, something like that. So that's the way how they will move with this place, going towards the closest point of exit. So that will be to the refugee camps. We stopped tracking these agents from the refugee camp to outside, like let's say to Europe or to Canada, to the States, elsewhere, because it was difficult for us to establish how to track them and how to make that decision possible. We were thinking it will be based on human, familial relationships in some cases, opportunity in some others, like like let's say Canada is opening so and so many places to bring refugees here. But we stop it there. So once the immigrant agent arrives to the border where the camps are located, so they will convert into refugee agents. If you can pass it to the next slide, please. So finally, this is what we have after the simulation is run. So the time steps or the time frame in total is 1 year or 2 years, I'm sorry. And then we were simulating on a monthly basis due to the fact that that was the data sets of death toll that we were having, that we were gathering. So, so the redder the path is, that will show the concentration or the path chosen by the immigrants. Next slide, please. So this is a total, like the output of the simulation that we have so far. So we started simulating on 2012, March 2012, and we simulated on monthly basis until December 2015. I just wanted to highlight that the data set is available from 2011, and it's a project that is going on. I refer to the crowdsourcing data set, and it's open and will be open until 2030. Those data sets are being, like, of course, they're citizen journalists that are gathering them, but they are validated once they are submitted to the website to ensure accuracy. So next slide, please. So, well, for this kind of simulations and this kind of models, it's kind of is somehow difficult to validate the results. So what we tried to do was actually just count the numbers and the proportion of the numbers in the end. So we were looking for the information on the refugee camps, the possible destinations for all the Syrian refugees. So we took Iraq, Jordan, Lebanon, Turkey, and we tried to identify the proportion of change. So let's say how many people it has augmented or increased or decreased. And then what we tried to do was compare our data set, like the outputs of our simulation model, with the real data set. So you can pass it to the next slide, but that's the end of my presentation. Probably in the question period, we could discuss a little bit more, but yeah, the challenge is the model phases as the input of data set. Nevertheless, if you have the data set, the model can be run anytime, at any time. We were trying to actually just build a way to identify the more frequently paths visited by immigrants once they decide to move. So the likelihood to use this kind of simulations will be in a way where you will have to send humanitarian aid to intersect this immigrants and facilitate the way for them to arrive to the refugee camps. So thank you very much. I think that's the end of my talk.